Okay, good afternoon. Any questions? This recording? Let's see what it is. Any questions? Any comments? I have a question. So go ahead and fire up your Piazza. Oops, okay. Maybe not. Oh, I see. Yes. Get this thing away. All right, so what I want to know from you is, in your own candid opinion, why are we doing this stuff with the midterm when it's so traumatizing? So I was thinking about that, and so let me set this thing up in Piazza. Other 21. One. Let's see. Choices. 1, 2, 3, 4. Okay, so we'll make this completely anonymous. Okay, so let's do this quick. So all I want to know is why you think we're doing the midterm. So I give you 4 choices. Can everyone read this from the back? Your eyes are better than mine. Just give me what you think is your best one. I just want to know. And then I'll tell you why I'm asking. Some answers. Okay. Oh, I have a lot of answers. Okay, that was fast. So interestingly enough, so 2 of these questions were there for of 2 of the choices were focused on me, right? tell me whether everyone's mastered the material. That's that's so that I know. The other one is to tell me, who's doing the best and the second best and so on. Interestingly enough, no one picked that one. Even though for me that's actually would be pretty useful, because at the end of the semester I have to give grades, right? I mean I have to. Right? If I don't turn in grades, I get in trouble. So for me this is actually a somewhat useful thing. And if you ask any of my colleagues, they would say that's probably the most important reason they give exams, right? They have to come up with a grade at the end of the semester. A bunch of people need to get A's and a bunch of people need to get B's. You can't just give everyone an A. Can't just throw darts at the wall. So that's a reason why a lot of people give exams. And some people want to make sure that the students have in fact mastered the material. You feel that you want to most of you felt, because that was the majority opinion, that you want to get feedback, what you know and what you don't yet know. And I'm with you all the way. I think that's the most important reason why one gives an exam, so that you honestly know, what do I know and what don't I know. And as I was Googling what are exams good for, what are the purposes of exams, there was some judo instructor who said exactly the same thing. He said the only purpose of an exam is so that the student knows what is it that they know and what is it that they don't know. And so someone was asking me after the last exam, that's a weird exam. Do you always give exams like that? And the reason I always give exams like that is they give you a pretty good idea what you know and what you don't. So I'm going to grade on a curve. I haven't looked at it yet. I haven't had time to put out some fires. And so I don't really care whether the highest score is 20 or 40 or 50. I have achieved my purpose. You now know that there's a bunch of stuff that you really want to get better at. And I would just do the grades because I am mildly interested in goal number 2 as well. But I'm not really interested in these multiple choice exams where 90% of the class gets 90 points out of 100 or more, because they don't really tell you what you know and what you don't know. It's inconceivable that 90% of the class know everything. And so I was talking about that with another professor who said that actually it's bad to give these kinds of multiple choice exams, because they implant in the mind of the student that that it's okay to have what's called a fixed mindset. Did anyone ever tell you what a growth mindset is versus a fixed mindset? It's a common thing. So some people seem to think that the way they learn is they have a certain potential, and that potential is somehow God-given. And so as long as they kind of get to their natural potential, then that's fine. And there are other people who say, well, they can always get better. They're probably naturally not very good, and they can always get better. And it turns out that students who have that kind of mindset, that they say, well, I'm clueless, but there's hope, I'll be better tomorrow, that they have much better chances of getting ahead. And so for students who are told, oh, I know, you know something, but you don't know everything, and who then can say, well, I don't know everything, I better get smarter, and I can get smarter, then that's usually a good attitude. Whereas if you're always fighting for, I get the 85th percentile, the 90th percentile, that's not actually all that effective. It may be more gratifying, but it's not that effective. And so, I'm sorry that I'm not very good in giving you confidence, encouragement, and gratification. But that's just not what it's all about. If you want gratification, don't get into computer science. I say that after a sleepless night of having to debug something that I've only found the solution like a couple of hours ago, and I feel really stupid. Yes?
Make a recommendation.
Yeah?
Just because I found one of the challenges with this exam is limited screen space. So it might be helpful if during the exam you put like the main page with all the questions up on the board.
I could try that. Yeah. Yeah. Sure. Seems like a cheap throw. And and it certainly can't hurt. I mean, I could print out some stuff if it's really helpful. I hadn't considered, because I guess I'm so used to juggling the screen. The one thing that I noticed that I wish really everyone should pay more attention to is that you've got to be able to deal with files in real time. When you get a zip file and you unzip it, you just have to know where the heck does it end up. So I've seen a bunch of people that were struggling with setting up their Eclipse project, with making sure it's at the right place with the GitHub thing. That thing's just practice. But it's super important. You have to have in your mind kind of two visions of the world: the one that you see from inside the console window, and the one in the tree of files. And you have to be able to match them up. And for a freshman who just starts out, that's a humongous hindrance. We get students who've never seen a file system, but now you've been at it for a few semesters, so now you really should make a conscious effort to get really good at that. And that does mean to use the pesky command line at every possible turn. So every time, fire up the console, do an ls to see where you are, and map that where you think you are. Use the command line. The more you use the command line, the more these things get ingrained in you, and the faster and more efficient you are with these kinds of things. All right, so back to what I really want to talk about, namely the end of this actually rather useful chapter. So I'll be following the textbook slides here. So you read up about until the strategy pattern, and I'll pick up a little bit more about that. But to prepare you for the last homework before the project, I want to get through this material on the composite pattern and on the decorator pattern. So first of all, some basic GUI information. This is true for all GUIs, whether it's Swing or FX or Android. You have GUI components, and you want to be able to collect them. You've seen that when you did the reading with the layouts, where you had these layout managers that arranged things that were put in a panel or something. So see where we have a picture. So over here we have like it. So we have some kind of a panel. That panel contains a bunch of individual user interface components. Now it can happen that you then want to take the entire panel and stick it inside another panel. So for example, you may want to take this entire thing and then stick it inside here, the south area. Well, what can you stick inside the south area? You can put in a component. So it really is useful that the panel by itself is also a component. So the funny thing is, it has components inside. A panel is a collector, is a container of components, and it also is a component. That's the way it is, and that's. Well, you can have it one way or another. You can have a class, or it can be an interface. But in this case, a panel is a class. A panel implements. Well, in this case, it extends. In the homework, we're going to do it with interfaces. So over here, we're having that a container extends component. It's a subclass of component. And it also contains components. But if one had it with interfaces, as you'll have it in the homework, where you're going to be collecting icons in what I'll call a composite icon that sets them all on top of each other, then the container implements an interface, and it also has objects that implement that interface. So the thing that makes the composite pattern characteristic is that you have something that both has something and is something. So you have primitive objects, that would be the components that can be combined to composite objects. That would be the container that holds them. And you also want to be able to use those composite objects as if they were the simple things. So in this case, the solution is that you should have some interface type that's an abstraction for what we call the primitive objects. Now, ideally, something like component should be an interface. In Java, it happens to be a class, but the pattern says, we'll do it with an interface. That's okay. Composites collect primitive objects, sure. And the key here is that the composites and primitives implement the same interface type. So in our case, like a J button and a J slider or whatever, they're all components they're all components, and a panel is also a component. A container is also a component. And then it finally says that when you implement a method from the interface type, the composite class applies the method to its primitive objects and combines the results. Let's make that one a little bit more tangible. Let's say that we have a container over here. I want to redraw this. F. Yeah. Then we have like this kind of container here, and it contains the individual components. And what method might I call on the container? Let's say I call paint on it, paint component. Then how's the paint component of this panel here, what's it going to do? It's going to call paint component, paint component, paint component, paint component, paint component, paint component, right? That's exactly what it's going to do. Let's do another one. Let's suppose we want to compute get width. Then we do, in some way, have to call the get width on each one of them and then combine them. I guess we also need to call get x to find out where they are. But again, we call the method on the individual ones as well. So that's the fourth characteristic that the pattern teaches us. So those four things have to be there to be composite. So here's a little picture. And so in the picture, let's see whether you can see this phenomenon that something both is and has something. So here's the composite class. And notice that the composite class has a bunch of primitives. You see the has arrow here, the diamond. And it has a bunch of them. That's why there's an asterisk here. And the composite also is a primitive. If you leaf node, that would be something that's like a JBuck, for example, also is a primitive, but it doesn't have. Now here's the comment that says any method that you call on the composite then invokes the equivalent methods on the things that it contains. All right, so that's a very nifty pattern. And it's really easy to remember the pattern because of components and containers in Swing or FX or whatever user interface system you have. Let me give an example to test this whole thing. Let's say that we're working with files in Java, with files and directories. Did anyone ever work with files and directories? No? There's two classes that one can do that. There's a more old-fashioned class called file, and that's the one that I'm going to be using here. Let's get the Java doc up real quick. So here it is, Java IO file. It represents a file in the file system. And there's a method here called isDirectory or isFile. So you can have a file object that represents a regular file, or it can represent a directory. There's a method called listFiles. When you call it on a file, I think it doesn't work. It gives you an empty list or an exception or something. But when you call listFiles on something that happens to be a directory, you get back an array of all of the files or directories that the directory contains. You know, the kind of thing that you would want to have if you need to program something and search for a file somewhere in a directory. So that's the file class. And my question is, does the file class, as I've just shown you, is that an example of the composite pattern? At first, it seems pretty promising, right? A directory is kind of a container of files. It has a bunch of files in it. And so the problem that we're trying to address is certainly the same. Primitive objects can be combined to composite objects. Directories can contain files. Clients treat a composite object like a primitive object. Well, that's what we want, right? Sometimes we want to work with files, sometimes with directories. And these guys in the Java library with Java io.file, they solved that problem by making file kind of do double duty. But it's not an example of the composite pattern because the way they solved the problem is different. It's not saying that the way they solved the problem is bad, it's just different. They didn't follow the pattern. They did not come up with a class directory that has files and also is a file. In fact, they didn't come up with a class directory at all. Yes?
How about in Linux? Because in Linux, everything is
Well, I didn't care about Linux. I asked about java.io.file. So when I ask a question about java.io.file, I'm not asking about general goodness. I'm asking about a very specific thing, and that'll happen again in the final. So I'm asking, is this particular thing, did they follow the pattern or didn't they? And in this particular case, they didn't follow the pattern because they did not make two separate classes. They didn't make a class for directory and for file. They didn't make a common super interface where both file is a something and directory is a something. You know, I'll just make it up. If I wanted to follow the composite pattern, this is what I could do, is I could come up with an interface, fileable item, just making up. And I could say a file is a fileable item, and a directory is a fileable item, and a directory has fileable items. That would work, and it would be a good design, I think. It just happens not to be the design that they chose.
what they have there.
They didn't follow this design pattern. That's all I'm saying. I don't know if there is a design pattern for what they followed. I mean, you can always make your own, right? But they just did not follow this particular design pattern. And so the point that I want to get across is that a design pattern is a very prescriptive thing. It says, here is the solution that I, Mr. and Mrs. Design Pattern, say, you should follow if you love me. And it is something that, you can choose to follow, and I would suggest it's oftentimes a good idea to do it, but sometimes it's not there, and you have to be able to know what it is. And so you can't just say, well, just because something contains other things, that means we have the composite pattern. It really has to be true that the solution is followed step by step by step by step. All right, so that's the composite pattern, super useful pattern. I want to motivate one other pattern that's also very useful. So let me first show you how a specific version of that pattern is used in Swing. So over here you see, sorry, it's so small, you see a window that has scroll bars. And that's, of course, something that often happens. You have something inside the window, you need to be able to scroll. There's kind of two possible ways of doing it. One could make it so that maybe the panel class, or the container class, or the component class, or some class has like two Boolean flags that say, is there a vertical scroll bar, and is there a horizontal scroll bar? And if those flags are on, then it paints the scroll bars, and if it's off, then it doesn't paint the scroll bars. There are user interface toolkits that work just like that, where you have a panel, for example, and the panel just has the scroll bars as properties that you can turn on or off. But that's not what Swing did, because Swing said, well, which class should be so privileged that it has those scroll bars? And they said, we're going to instead do scroll bars as like a universal add-on feature. That if you have any component at all, and you want scroll bars, then you wrap that component inside a JScroll pane. A JScroll pane is another component. In fact, yes, that's another component. It's not a container. You can only put one thing into a JScroll pane. So it's another component, but it wraps a component and endows it with scroll bars. And that's actually very flexible. Right now you can put scroll bars on anything. You want to put scroll bars on a button? Go right ahead. And maybe not very useful unless the button is very large. But you want to put scroll bars on something that inside which you painted some big old scene with cars and trucks, then you can do that and it'll scroll. So I'm not going to get into the mechanism for the scrolling right now. But the idea is that you get any component, you stick it inside a scroll pane, and this is the kicker, you again get a component. So that means you can now deal with this thing here exactly as with any of the other components that you already know. You can stick it into a panel, you can put it into the south area of a border pane, you can move it around. You know exactly what to do with the component as a user interface programmer. And this thing takes a component and turns it into another component that is somehow different, better, nicer, more decorative. Yes?
In this example, does pane become like a container that's
No.
a component?
It's
Or
not a
you can still deal with them separately.
Well, you can still access the component, like, for example, you want to set the background of this to pink. You do that to the component.
You can't do it through pane.
I don't know what would happen when that would flow through. It might.
But why isn't this a container? So,
Oh, you can only stick one thing in there. It doesn't really make sense
Oh.
to put 5 things into a scroll pane. I mean, that would be really confusing. What would that mean?
but if you put there, so they're like cover each other, or it's like.
That's why it's not. That's not why it's not a container. It takes a component and decorates it into another component. So it takes a component and yields a component. That's a different kind of component. And so that pattern, in general, is called the decorator pattern. And so in the decorator pattern, you have some component objects that you decorate in some way. Where decorated means just whatever you want it to mean. They become different in some way, but not too different, because the decorated object can be used in the same way as the undecorated object. So in the case of a scroll pane, it still is a component. You can still do with it the same things that you can do with a button or a pen or whatever. And the component class doesn't want to take on the responsibility of the decoration. That's why I say, of course, it would have been an option to make it so that every component in Swing optionally has scroll bars. You had a question?
If you initialize the scroll pane with the component and later, let's say you increase the width or the height of the component, you need to do something with the pane, or does it automatically?
Well, the decorator picks up on that.
Okay, so you're not like.
So it'll lose the scroll bars. The scroll bars will only show up when they're necessary, actually.
Oh, okay.
So if you resize the thing that's inside, then the scroll bars will magically go away.
But let's say you increase it.
Oh, then they'll come, yeah.
Oh, okay.
Yeah, one way or another, yeah. And there'll probably be this exact one corner condition where you can't win, where if you put him, you know what I mean? I mean, there's always this one awkward position with scroll bars where they're just not necessary or just not necessary. But they'll do something. That's the job of this JScroll pane to figure out when to actually show the scroll. But the point is that the component class, the panel, doesn't want to deal with it. And so you want to segregate that responsibility into the scroll pane. And this is best done when there is some open-ended set of possible decorations. Like what else could one do with a pane? I guess you could maybe want to put it, or with a component, maybe you want to put like a box around it or some other kind of decoration. There aren't actually very many other things that you can do in Swing with components. JScroll pane is pretty much alone, so the open-ended thing is a little bit iffy in this context. So the solution then is to say, have a common interface type. The components should realize this interface type. Again, in Swing, that's not really well done because the user interface components, they are classes and not interfaces. Ideally, they should be interfaces. The decorator classes also realize this interface. And so that's what I'm saying, that a decorator takes something and turns it into something else of the same interface. It takes a component, it makes it into a component. And, of course, the decorator object manages the component object. I think that's why some of you were asking, is it a container? And it kind of is a container of one. It just contains this one thing inside. And, of course, how does the implementation work? How does a JScroll pane paint itself? So here we have a JScroll pane. Now we're going to say, hey, you paint yourself. Well, what's it going that sits inside, and then also paint its decorations. And that's, of course, exactly what it does. In fact, that's exactly what makes the JScroll paint really work. Imagine you've adjusted the scroll bars this way or that. Then it's cleverly painting the inside so that it's shifted by the position of the scroll bar. Note also that when that happens, the component has no idea that it's happened. The component is utterly unaware that it is being scrolled, which is kind of nice. This works, in fact, so well that when you click with the mouse on here, that the container will adjust the mouse click coordinates. I shouldn't say the container, that the scroll pane will adjust the mouse click coordinates so that the scroll pane, that the pane inside, that the component inside, never knows where the mouse actually clicked. It's being told, oh, the mouse is clicked so many pixels away from your origin, even though the origin may be hidden. So all of that translation is done by the scroll pane, and the actual component doesn't have to worry about it. So that's a super useful thing. In fact, it is so useful that you find it elsewhere in the standard library. And so the kind of classic example is with readers. So you may know the difference between an input stream and a reader in Java. A stream reads bytes and a reader reads characters, depending on whatever encoding system you have. I should really fix this up to put the encoding system in here. So reader reads characters. And then you can take a reader and turn it into another reader. There's a decorator called the buffered reader. And the buffered reader makes reading a little bit better. What it does is that, let's say that you just started out reading the first character, the buffered reader says it's stupid to read one character at a time because then you'd have to go back to some OS level call for the next character. Instead, I'm going to be speculatively reading 1024 characters and put them in a buffer. Next time I'm asked to read something, I will just fetch it out of the buffer. Eventually the buffer will be empty, and then it'll get filled up again. But that's a good optimization strategy. And so the buffered reader applies that optimization strategy to any reader. That could be the reader that I got here from an input stream reader. I might be getting a reader from somewhere else.
Why is that? How is it useful?
Okay, let's first make sure that everyone understands the benefit of buffering. Because buffering is a big win in practice.
Is it to reduce disk reads?
It's to reduce stepping down to the operating system. When you call read on a file, or in this case on standard in, and you just read one character, which means you read a byte, you test whether that's a complete character, then you read another byte, and so on. That is slow. Because each time you have to to go down to the kernel and say, give me another character. And so it's much better to say, give me a whole block of characters, and 1024 works just about as good as anything. That way you basically cut that down to a factor of 1,000. And so that is a big one. So the way it's done in Java is that the buffered reader does that. Now, they faithfully applied the decorator pattern in this case. So we have an interface called reader that's implemented by both the input stream reader, that is a raw, one character at a time reader, and the buffered reader, that's the decorator. So the buffered reader is a reader, and it takes a reader. Unlike the composite pattern, there's a slight difference in the UML diagram. So you kind of have the same picture, that a decorator here is whatever the basic thing is, and it also has, but notice it has exactly one. So in the UML diagram, that's really the only difference. So you kind of can think of a decorator as being a composite of one, but the purpose is a little different. With the decorator, we don't just want to collect things, but we want to modify them in some way. We want to modify the behavior. So back to, and this is a little subtle, back to this particular pattern with the buffered reader. So in Java, that's what you do. That if you want buffering, you take your regular old input stream reader and you turn it into a buffered reader. In fact, my fingers know this by hand. I just have to type BU and they go off on its own, and type buffered reader of new blah blah blah. Yeah.
Can we go back to the graph?
Yeah.
Is actually the concrete component contains the? It's a decorator.
No. The concrete component would be the input stream reader, the file reader,
Yeah.
the concrete reader. Okay. Now what's your question?
So actually the decorator will contain instance of the.
Okay. So that's everything. So let's look at the buffered reader. Doesn't the buffered reader hold an input stream reader?
It's called a.
It holds some reader because it might contain a file reader.
Right, the component, the interface.
So it has to contain the interface. That's why the arrow here goes up. Yeah, maybe this is not a very good drawing, but the arrow goes like this. Yeah, so the arrow does not go from here to here. So, so back to this pattern here, right? So we have an input stream reader, or maybe we have a file reader, and we know that to get buffering. Those of you who know C++, how does it work in C++? Or in C? Or in Python? Or in Go? Yes? Do you know? You were raising your hand, or you just... Were you raising your hand? Okay. So how does buffering work in those languages? Like when you read input from a file, say in C or in Python. What do you say?
You have to have a file pointer, or kind of like you have to open the file first.
And is it buffered or not?
No.
Is it buffered?
Not
Oh no. So in C, from what, 1980? Always buffered by default. It doesn't make any sense not to buffer. It's so cheap and so easy to implement and so obviously useful that no one in their right mind would not want to have it buffered. So in C, it's always buffered. In C++, it's always buffered, and you can actually, although I've never actually really had to do that, but you can actually replace the buffer with something else for whatever reason you felt the need. So people who wrote programming languages for real use, they knew that buffering is just so essential that having it as an optional thing makes no practical sense. The Java people were maybe a little bit too enamored with this particular design pattern that they said, well, we'll give you the choice between something you never want, namely the unbuffered, and the buffered, which then you have to laboriously put together your buffer. So, so when you do the decoration, it's a good question to say, what is it to be? Is this really an optional thing that where the cost of having to add it in is worth the flexibility? And so with scroll bars, they felt, yes. But I've seen other user interface toolkits who said scroll bars are so universal. We'll just make a class where like every container can have a scroll bar. So that's so it is a bit of a judgment call. But anyway, the decorator pattern is there. It's alive and well, and it often is very useful. I must have used that pattern in 10 different contexts over the last few years to build up these kind of hierarchies where something can be decorated one way or another way or a third way, and then you can mix and match them, and it is a flexible approach. Yeah.
Can we also apply this design thinking to Python language?
Yeah, to any language.
Is there any difference?
No, I shouldn't say that. I'm not sure if we get to that in this course. When you later get to some of the most sophisticated patterns, there's a pattern called visitor, for example, that teaches you how you can effectively visit all of the nodes in a tree. And so the visitor design pattern is very complex. There is 2 levels of callback. And that is necessary because if you have a strongly typed object-oriented language, you need that. In a functional language, the whole pattern kind of goes away because you can just apply a function to all the nodes. So the design patterns are somewhat sensitive to the language, and there's some people who say that if you have a design pattern, maybe it means there's a weakness in the language. Maybe the language should have a better way of expressing that. And so I think they're thinking of the visitor pattern specifically in that. For other design patterns, like the composite pattern, that's useful in any language. The decorator pattern is useful in any language. So I would say there's some patterns that kind of point to weaknesses in the language, and there are others that are universally applicable. So, when you want to recognize patterns, and it is a good idea as you go and you study how people solve different problems to find these patterns, because then you can learn how other people applied them successfully and how you can apply them. You have a catalog of patterns. By now we know like 5 or 6 or 7 patterns, and we'll sneak in a few more as the course goes in. I think the Gang of 4 book has on the order of 30 or so, and I must say, if you asked me, standing right here, whether I can tell you with precision what the bridge pattern is, the answer is no. I would have to look it up. But everyone should kind of know, the most common patterns, and it's certainly a fair interview question. Is this an example of a decorator pattern? That's easily something that you could accomplish.
I mean, the wrapper patterns that are very similar.
Well, and so when someone tells you something about a wrapper pattern, then it's good to know that that's not one of the standard patterns. It's something that they must have invented. You could say, "Tell me about your wrapper pattern," and you can have a discussion about how that is similar or not similar to the decorator pattern. Someone who can carry on such a discussion gets hired in no time. So one of the things when you look at these patterns is you can look at these very dry formal descriptions, and that's important because you need to know those to see where the pattern actually applies. But you also want to look at the intent of the pattern, and so you need to be able to merge both of those. So usually one starts with the intent when seeing does a pattern group. So the intent of the composite pattern is to gather a bunch of stuff and then have the unit be the same as the individual pieces. So the gathering is the important, that's the intent. The decorator pattern, the intent is to take something and turn it to something of the same kind, but prettier or nicer or different or more efficient or modified in some way. So there we're not trying to gather multiple things, but we're trying to make one thing nicer. So that's a different intent. Otherwise they sound very simple. Now, one of the key things though is that when you look at a pattern such as the strategy pattern, it's very easy to get to look at the word and say, well, strategy, that's obviously a good thing. And then someone gives you some context and says, it's just an example of the strategy pattern. You say, well, gosh, that sounds pretty strategic. But that by itself doesn't really tell you much at all. The strategy pattern has a context and a set of solution steps, and they really need to be followed. So I have an example of that. So here is something that you do in Swing. If you want to put a border around, say, a component or a panel that contains components, which is a component because of the composite pattern, the way you do it is you make a border object. So here I make an etched border that kind of looks as if it's etched. And then you call component.setBorder. And so over here, I've done that. I have a panel that contains these 2 buttons and another panel that contains these 3 buttons. On the first one, I made a border that is labeled in some way, and here I make another border. And each time I say panel 1.setBorder, panel 2.setBorder. Well, it's decorative. Is it an example of the decorator pattern? Why not? Yeah?
Is it because the component is having to do the work to set the border?
Exactly. Very good. So it's the component that does the work. And one of the things in the decorator pattern was that the component is blissfully unaware of that it's being decorated. Here the component takes on the decoration on itself, right? Yeah, a method called set border. Here's another way that you can tell. What if you want to set two borders? You want to have both an etched border and a shiny border. You can't, right? Because there's only one called a set border. With a decorator pattern, you could, right? If there was a etched bordered component and a shiny bordered component, you could apply one after the other. For that matter, you can have a button with two sets of scroll bars, right? You make a new J scroll pane of a new J scroll pane of a button. Not that it's very useful, but with borders it actually might be potentially useful. Right? But you can't. So this is not a use of the decorator pattern, and it's kind of a shame. That would have been a nice way of doing decorations, except of course with user interfaces. I mean, how many borders do you have, right? I mean, you're not in a real life user interface going to have like two sets of borders. So that's why they did do. So here, when you follow this through step at a time, component objects can be decorated. Yeah. The decorated object can be used the same way as the undecorated object. Yeah. The component class doesn't want to take on the responsibility, and that's why the component class is the one. And so it just means it doesn't fulfill this pattern. It doesn't mean it's bad. It doesn't mean it's good. That's just the way it is. So you want to be able to understand when these patterns apply and when they don't. All right, so I'll briefly go through this through this project here at the end of this chapter, and so there I wanted to give you one more way of seeing all of these patterns in a single application, which may not be a very useful thing to do, but that's what I set out to do. So you're going to be seeing every one of the 5 patterns in this chapter in this in this invoice application. So let's look at some code here. Let me blow this up. So in an invoice, you have line items, right? You sell certain things, and so a line item is something that has a price and it has a description, which we just get here with toString. So you want to sell a bottle of beer for 99 cents, then you get the price, the description. That's what a line item is. Here we have a class product. A product is a concrete class that implements line item. And it implements it in the most boring way. Namely, it has description and a price, and its getPrice method returns the price. Its toString method returns the description. Whatever. So you might say, why even bother with that interface? There seems to be no difference between a line item and a product, right? They both have a price and a description. But here's why. And so consider selling a bundle of stuff, a set of items presumably somehow related. And so to see just how ancient this example is, what's a stereo system, right? But it used to be that people would buy stereo systems with tuner. Yeah, what the heck is a CD player, right? But so speakers, right? That's one would go to the store and they would have this bundle of pieces at a 10% discount. What's a bundle? A bundle has line items, right? It has this thing, this thing, this thing, and this thing. Each of them has a price. So a bundle has line items. And a bundle is a line item because on your invoice it might say, one Thanksgiving bundle for $299 or something. It is a line item because you just buy the bundle and it might have a different price. So that's where the composite pattern is at work, because a bundle has line items and a bundle is a line item. It's actually a very nice example, if I may say so, of composite pattern. So let's see how it's implemented. Because a bundle has line items, it has to collect them. And the easiest way to collect anything is in an array list. Here's the array list. So here is the constructor. We have to have a method of adding things to the bundle, and that's done by the add method here, where we simply take a line item and add it to the array list. Now we need to compute the price. Well, what's the price of the bundle? It is the sum of all of the prices of the things that are inside. So that's, again, a hallmark of the composite pattern. To call get price on the composite, I have to call get price on each of the individual pieces and then combine the answer. What is the description? Well, the description here is bundle followed by the names of each of the things. So one could prettify this thing a little bit and maybe make the bundle sell at a discount. I think there's an exercise there like that, where you could specify a discount in the constructor over the individual item, or where the bundle might have a name, and then the name would be put into the description here. So this thing just shows the most basic parts. But so that's another really useful way of looking at the composite pattern. Now, why do you care? In the next homework, you're going to have to do a composite icon. So a composite icon has a bunch of icons and draws them on top of each other. So that code, when you look at this example, will almost write itself. Public class composite icon implements icon. Public icon. Sorry, public composite icon. Icons equals new array list of icon. Public void add. Same thing. Okay, of course with an icon we don't have a price. But with an icon we have to paint it. How do you paint the composite icon? You're going to have to go through each of the individual icons and do something with it. With an icon you need to compute what the width, get icon width. And how do you compute the width of a composite icon? So you use a composite icon, maybe you draw a car here, in front of the house, and then you have the sun here. Now a little suburban scene here. So how do you compute the total width? How wide is it? What's the one of the icon interface has three methods: paint icon, get icon width, and get icon height. Paint icon, we have an idea what we need to do. Paint. How do we get the width?
It's also going to be related to the position, right?
Well, so the way that we're going to do it is they just get drawn exactly on top of each other. I didn't want to mess with the positions. Yes, I understand what you say. You then would go for the widest one, right? You simply see which one is the widest one, and that's the total width. All right. So that's the composite pattern here with the bundles. So the reason I'm giving you these various examples is that to make these patterns a bit more concrete. If you can remember, the composite pattern is just like containers and components, like line items and bundles. Then it gives you a couple of examples in your mind, and that's, I think, easier to understand than the theoretical description. All right. Now here I have another thing, and I shouldn't have told you what it is. So when you have an item, you may want to give a discount on it. Now, a discounted item, the way I'm going to do it here is I'm going to say it's again another item. So a discounted toaster oven is another item. I'm going to be using a decorator for discounted item. So you can take any item and turn it into a discounted item with this decorator. So here it is. Discounted item implements line item. It takes a line item and the discount. It stashes away the item, only a single one in this case. It stashes away discount because it's needed later. In the get price method, we're asking the item, what's your price? That's the undiscounted price. And then we apply the discount. Why 1 minus discount over 100? Okay, let's say the discount was 10 for 10%. Then 1 minus 10 over 100 is 0.9. And so notice that the decorator decorates a single thing. The method on the composite then, the method on the decorated thing calls the same method on the undecorated thing and does something. The same thing here with the description. We call item.toString on the undecorated one, and then we put in parentheses the discount. Notice that you can even give a discount on a discount, right, by decorating twice. Yes?
That's kind of like what we did on the filtered number sequence.
Yes. A filtered number sequence was a number sequence. That was a decorator. That was a decorator, right? So you take a number sequence and you modify it in some way. Yes, so you can say that it definitely. And the filtered sequence, the filtered number sequence, inside it, if you remember, has a sequence, right? That's what I wanted to see in the exam with that sequence diagram, by the way. Now, this is not the only way you can deal with discounts. I could have simply taken my line item interface and added a discount in there. But then the disadvantage is that every line item potentially has a discount whether I use it or not. So a decorator is really useful if you only occasionally want to decorate. Then that way you don't clutter up the basic thing, and you still have the freedom to do that. And that was kind of my beef with the buffering. With the buffering, it wasn't the case that you only occasionally wanted to do it. You almost always want to buffer. And so there, maybe the decorator pattern wasn't such a great pattern to apply. So decorator pattern is useful if you want to have, like it says in the pattern description, lots of different kinds of decorations. And also, there should be something in there that says you don't always want to have it there. So now comes something a little bit more complicated. That there's a GUI for this program. In fact, let me take a minute to just do that. Not much of a GUI. Oh, no, it's okay. Okay. So apparently I can like add some things to the invoice. That's all I can do. And so let's see what we want to achieve here. So the GUI has commands to add items to the invoice. And the GUI also displays the invoice, as you've seen every time that I've added something here. Where was it? then the thing got updated, right? As for fun add. Another one, you see the total gets updated. And so I want to be able to decouple the input from the display. So the input is what the button does and the combo box. And I don't want to make it so that like the button starts rewriting the text field, right? I could do that, I guess. I could, have the code for the button like start inserting text into this text field. But I didn't want to do that. I wanted to decouple the input from the output. So the display part should know when the invoice is modified, but it doesn't really care which command modified the invoice, because ultimately all that the display cares is to call toString on the invoice and have the whole thing being displayed. So we want to have a situation where whenever the invoice is being changed, that it's going to tell someone, in this case the display code, I've been changed, deal with it. And whenever you have that situation, it's called the observer path. So we wanted to make it so that the invoice can register observers. And that is useful to know how to implement that, so we put that in here. So there's a standard way of doing this in Java with what's called a change listener. There's an interface called change listener, and it has a method called state change that gets called when the state of something changed. And the change event has something in there that has like the old and the new value that we're not really going to be using. So we're going to make it so that the invoice object is it has a collection of change listeners, and anyone can say, hey, let me know when you've changed. And then when the invoice changes, it's going to go through all of its listeners and say, so if the listeners want to say, each of them want to invoke the state change method. So that's all kind of abstract. Let's see how one makes use of it. So in the display class, that does the displaying, there's an invoice that's being made. That invoice gets updated through some button action that we're not seeing here. In fact, we don't want to see it. We want to be decoupled from it. But when the invoice changes, then then this change listener is going to get kicked in. Somehow I'm not adding it. Get that line. Yeah. Oh, that totally sucks. So here I wanted to say invoice. Change listener. Listener. So that's important. So the listener here is constructed. It simply calls set text of an invoice.get text or invoice toString, whatever the call was, when the change happens. But of course, I want to tell the invoice, this is the listener that I want you to call every time I change. So now if you follow through the flow that says a button gets clicked, then there's a button action that will add something to the invoice. So resolution is not wonderful. Someone will call add on the invoice. And when that happens, the invoice is going to on itself call something like notify listeners. And that's going to go through each of the action listeners, change listeners. So there's going to be some change listeners out there. That's going to call one of them. Does anyone remember what that method was called? Change listeners. What the? State change. Thank you. It's going to call state change on that. Now we don't see that with the lambda, but this really here is the state change method. Right? This code is turned into the state change method. And then the text area dot set text is going to be called. So that means the button gets clicked, the button callback calls add on the invoice. The invoice simply doesn't know anything what's doing. It's just notifying its listeners. That's going to get controlled to this change listener. That's going to trigger the text change. It's a complex set of changes. They're too complex that I can't get it on my little screen here. And the whole purpose of it is to decouple the user interface input part from the display part. And that's where the observer pattern does its job. Just to show that I can do it, and I'm not going to go through the details here, is I've made it so that the invoice, which collects line items, gives you an iterator where you can iterate through the line items. Now you might say that's crazy, it collects them in an array list. You know, just give out the array list. Oh, why don't I want to give out the array list? So let's say someone wants to look at all of the line items in the invoice. Why don't I want to give out the array list? So in my invoice class, why don't I just say get line items? But I could make a public method that gives it out. So again, slowly. So I have an invoice class. It has an array list of line items. Why doesn't the invoice class wants to have a method that says get line items that gives out that array list? We have that in chapter 3. Yeah, there's a buzzword for it. So a class doesn't normally want to give out a mutable part of its innards. It's called the law of Demeter. The way that I call the law of Demeter is, hey, can I borrow your liver? Right? So generally that's not considered a good thing. But I could give out an iterator, and I'll show you here the code to do it. And there's one semi-plausible reason that the iterator is not totally crazy. What if I didn't store the line items in an array list, but what if they were stored in a database table? Then it would make perfect sense to iterate through them one at a time. So, now, I should say it doesn't, but it seems like it would make perfect sense. So the iterator pattern at work here, just to give you another implementation of it. So you know how iterator works, except iterator has a funny thing in Java that we may run into once or twice, that the iterator interface has 3 methods. As next, makes perfect sense. Next, the one that fetches the next one. Then there's a remove. Every iterator in Java has a remove method, even though many times you don't actually want it. This quite often happens that you have something that's read-only. You want to iterate over. Like this invoice. I didn't want to give out an iterator so that people can remove items from the invoice, thereby avoid payment or something. And remove is a weird method it's called an optional method. That's an invention of the guy who came up with this that I've never seen anywhere else. And so remove is allowed to throw an exception if you don't want to have it implemented. That's what my implementation is. Let's see how this implementation actually works. Yeah, I'm not crazy about remove because you often don't want it, and it is a headache. I don't know why they didn't come up with like a superclass iterator, a super interface iterator, and like a mutable iterator unread. But whatever, they did. So over here, you see the implementation of the iterator method. And so you get items, returns an iterator on line item. And there's one thing that I don't think we've really covered very well. Iterator is not a functional interface. It has 3 methods. Functional interface only has 1 method. So you actually have to list all of the 3 methods. The way that you've always done that is by coming up with a separate class. You would have an invoice iterator class that has those 3 methods, and then would return a new invoice iterator. It's possible in Java to make what's called an anonymous class with this syntax, where you say, return me a new object of a class that I'm not willing to name, that's why it's blank here, that implements this interface, and here are the methods in place. This syntax was very common before Lambda expressions came, and here we still have to use it because we can't use a Lambda expression. A Lambda expression can only be used with a functional interface where you have 1 method. Here we have, like, say, 3. So if you run across one of these things, I don't think you ever have to write them, because you could always give the class a name and then just make a new object of that class, just as you have done in the homework assignments, right? Where you had like a square sequence and a filtered sequence and all of that. You just gave them a name and it was good enough. But it's useful to be able to read it. And there's one thing that is also useful to know, and that is just like with Lambda expressions, because we've stuck this class inside another class, you can read everything that's around it. So we can read the current and its items in the current variable. The items comes from, where did it go with the current? Oh, the current comes from here, from this inside this class. The items comes from the surrounding class. All right. Did I miss any patterns here? I know I said I stuck them all in here. No, I think that gets me to the end of what I put in here. All right, so that's all. Homework will be posted sometime later tonight, so get with it. Next week we will start working on the project, so I will over the weekend put out some guidelines and figure out some way on how to gather people together. I wanted to be a little bit informed by the outcome of the exam for that. All right.